It's nature at its most savage and fearsome. Volcanic blasts spewing pillars of super hot clouds skyward, unleashing hurricanes of molten rock and fire. But as awesome as past eruptions have been, one coming eruption is destined to change life on our planet, killing millions of people, altering the Earth's climate, creating worldwide famine.
It would be so massive, would have such impacts that it's hard to fathom.
This would fully be a catastrophic event on a global scale.
And the source of this monstrous devastation lurks just miles below the surface of America's first national park.
We are directly over Mount St. Helens right now, and there is no question at all that the volcanic activity has begun.
May 18th, 1980, 8:32 a.m. A 5.1 magnitude earthquake rocks Mount St. Helens in southwestern Washington state and triggers the deadliest volcanic eruption in U.S. history.
Northwest side is right down. And what have we done, boys? The whole northwest section.
In minutes, a mushroom-shaped cloud shoots up 10 miles high. Below the cloud, superheated flows of rock and debris surge out of the crater, racing over the land, incinerating everything in its path. No one is prepared for the chaos. A river swollen with mud and debris rages out of control. The devastation is immense. Everything within a 230 square mile area of the mountain is obliterated. 57 people are killed, and thousands of acres destroyed. By midday, the eruption ends, leaving a once serene and beautiful region a wasteland. A graceful cone-shaped volcano is now a blasted stump. And a nation is in awe of nature's destructive power. But there's one volcano in the U.S. with the potential to wreak devastation on a far greater scale. It's located 575 miles away from Mount St. Helens, in the northwest corner of Wyoming. For over a century, tens of millions of visitors have marveled at Yellowstone's breathtaking scenery. But beneath this spectacular beauty lies a ticking time bomb. We get a glimpse of it each day from Old Faithful. Every 90 minutes, this famous geyser shoots over 8,000 gallons of boiling water 18 stories high. A tourist attraction, but far from benign. Yellowstone is one of the largest volcanic systems on Earth. Scientists call it a supervolcano because of the size of past explosions.
The criteria that we use to decide whether an eruption is a supereruption is essentially the volume of the eruption. And that is, if an eruption has more than 240 cubic miles or 1,000 cubic kilometers of pumice and ash that came out in that one event, then it's a supereruption.
There have been 3 super eruptions at Yellowstone over the last 2.1 million years. The last big one was 640,000 years ago. The one before that, 666,000 years prior. Which leaves many to wonder, What's next? There have been signs that something unusual may be happening in the park. In 2004, 5 bison were found dead in a geyser basin.
They weren't in a typical death pose, kind of like a cat that's curled up. It looks like they've just fallen over. We think it was just a very cold night, very still night. The geothermal gases accumulated, and the bison just basically dropped where they stood.
The gases were identified as hydrogen sulfide and carbon dioxide, 2 components of what's found just below the ground at Yellowstone, boiling hot magma. The Yellowstone supervolcano sits on what geologists call a hotspot. Unlike other volcanoes in the world, Yellowstone isn't cone-shaped with a crater at the top. Instead, it's a caldera, a large depression in the earth 50 miles long by 30 miles wide, formed during its last major eruption. You can be standing on the caldera without realizing you're standing in the crater of an active volcano, one that's erupted over 25 times since its last superblast.
Yellowstone is most famous for its very large supereruption. However, there have been a series of other eruptions. These are smaller than the supereruptions, but they're still enormous events, 50 or so times as big as Mount St. Helens.
Given its past, the next Yellowstone super eruption could be the largest natural disaster in recorded history. In our lifetime, we have nothing to compare it with. The Icelandic volcanic eruption in 2010 grounded flights around the world for a week, causing the biggest air travel shutdown since World War II. But it doesn't come close to what Yellowstone's capable of. A Yellowstone super eruption would eject over 1,000 cubic kilometers, 240 cubic miles of pumice and ash from deep within the earth.
Which will come out of the volcano and destroy everything in its path.
1,000 cubic kilometers is enough to bury the state of Texas about 5 feet deep.
It would be roughly the equivalent volume of the size of Grand Canyon twice.
The explosion would also release ferocious avalanches of hot ash, pumice, and gas called pyroclastic flows.
They're essentially like superheated sandblasting clouds, can destroy pretty much everything in their path through either knocking it down or sandblasting it to bits or setting the resulting debris on fire.
Case in point, the 1995 volcanic eruption on the Caribbean island of Montserrat. Pyroclastic flows surged down the mountain and into the capital city of Plymouth, burying it under more than 30 feet of mud and ash, rendering it uninhabitable. While pyroclastic flows sear the land, volcanic ash in the air is deadly.
This is a bomb. This is a bomb actually from Mount St. Helens, 1980 eruption. And when you're fairly close to the volcano and you get big globs of magma, lava that end up in the air, then they cool literally in the air and then come down as a big, heavy, solid chunk. In the case of Mount St. Helens, some of these bombs were this big or this big, but we've certainly seen in other places bombs that are as large as a house.
These bombs are mixed with tons of volcanic ash, but it's not the powdery residue you see in your fireplace. Smithsonian Institution geologist Ben Andrews is an expert on explosive eruptions.
Fireplace ash is essentially just burned wood. Volcanic ash is pulverized pumice and rock, smaller than 2 millimeters. And if we look at it with a microscope, we see that it's essentially little bits of broken crystals, little bits of broken rock, and bits of broken pumice. And if we look at that pumice, we see that it's glass.
A petrographic optical microscope reveals some details. But it's not until you see volcanic ash with a scanning electron microscope that you learn how dangerous it is.
So we're looking at a sample of ash from the 1980 eruption of Mount St. Helens here. And as we look at this, we can see right now that it's much more than just fine-grained dust. We have a piece of glass that then has some very sharp features to it. You see that as these points and sharp edges around it. And each one of these particles, in this particular field of view, each one of the big particles is about half the size of a human hair. In the case of volcanic ash, you're inhaling bits of broken glass, which effectively can lacerate your entire respiratory system.
If you're close to a super eruption, inhaling large amounts of volcanic ash can burn the lining of your lungs, causing rapid death. But further away, airborne ash will make it difficult to breathe. That can kill you too. Project managers at the Federal Emergency Management Agency take the threat of a Yellowstone super eruption seriously, mapping out 6 danger zones. Following an eruption, Zone 1, closest to Yellowstone, would be suffocated by up to 6 feet of ash. 70,000 people are at risk here. The ash cloud would reach nearby communities in a matter of minutes, leaving little chance for residents to escape. Travel 60 miles further to Zone 2, and another 400,000 people are at risk from over 3 feet of ash. There would be severe health problems on a scale that would overwhelm local hospitals and clinics. The deadly ash would spread quickly as it rises into the atmosphere. In Zone 3, more than 1 million people would be exposed. In Zone 4, Salt Lake City and Denver would be crushed by 1.5 feet of ash, twice the amount needed to collapse a building. Nothing short of a concrete bunker would support the weight. In Zone 5, cities as far away as Kansas City and St. Louis would see nearly 1/2 foot of ash. Even that amount can cause roofs to collapse. By the time the ash covers Zone 6, it would blanket an area from San Francisco to New York, from Dallas to Detroit, dumping about 1/2 inch, still enough to irritate lungs and eyes. In total, at least 200 million people would be affected by the ash fallout from the Yellowstone volcano. If the super eruption occurs without any warning, the human toll would be unimaginable. Even with warning, the impact would be catastrophic, with deaths in the millions. As for those who survived the blast, they would face a world of desperation and turmoil, caused by gritty, abrasive fragments raining down on them from the sky. The ashfall resulting from a supervolcanic eruption at Yellowstone would endanger the food chain. Crops in the heartland of America would be severely damaged, if not destroyed.
Well, the problem is that the breadbasket of North America is downwind from the Yellowstone volcano. And the ash that would cover the ground surface would destroy the growing season in the U.S. and Canada, and the world's supply of grain would be in trouble.
Even if food were available, distributing it throughout North America would be next to impossible. Aircraft wouldn't be able to fly because of ash in the stratosphere. It's why planes were grounded for days after the 2010 Icelandic eruption. Flying through volcanic ash is like flying through clouds of sand. The small, gritty particles can damage jet aircraft blades, affecting the engine's performance. This simulation shows what ash can do within a jet turbine when it strikes an engine blade made of titanium. In just 5 minutes, the ash blasts a hole through the blade, which could lead to catastrophic engine failure in mid-flight. While not as dramatic, ash can also disable ground-based vehicles.
Automobiles, their engines would get clogged with volcanic ash, so there'd be no trucks in the middle of North America. There'd be no way to get food in or out of that zone.
The volume of ash would pose the most serious threat to human health. Canadian Raoul Singh has responded to natural disasters around the world. As a paramedic and director of the charity Global Medic, he's seen the effect volcanic ash can have firsthand.
You know that people are going to need food, water, shelter, access to primary health care. The main difference with a volcano, the ash. The ash is the killer.
There's evidence of ash's deadly effects from 12 million years ago in northeast Nebraska. Here, at the University of Nebraska's Ashfall Fossil Bed site, are the skeletons of over 200 prehistoric animals that died from exposure to volcanic ash. The ash came from a volcano that erupted over 1,000 miles away in what is now Idaho. Researchers at the site scrape away layers of soil and sediment, revealing a scene reminiscent of the human tragedy at Pompeii. These animals survived the initial ashfall, but over time, as they grazed on ash-covered grasses, they breathed in the powdery glass dust that shredded their lungs. And here, at what was an ancient water hole, they suffocated to death. If you don't die from inhaling ash after an eruption, your next concern would be clean drinking water. Falling ash would contaminate rivers and lakes. Water like this would have to be filtered. And Raoul Singh knows about the consequences if it isn't.
Our teams are specialty in providing people with access to clean drinking water and access to primary health care. The ash is going to give us tons of patients, but in 2 or 3 days, that ash is also going to wreck the water source of all those people. So that same patient who may have treated on the first day of an event because the ash is what he inhaled and it made him short of breath and it's caused all kinds of problems. In 2 or 3 days, if you don't get clean water up and running, they're going to be a patient again.
The effects of a Yellowstone super eruption wouldn't be confined to North America. They would be global, triggering catastrophic climate change. It's happened before. Scientists use a numeric scale to measure the magnitude of a volcanic eruption.
So the Volcanic Explosivity Index, or VEI, is a way for scientists to measure how big an eruption is. It's similar to the Richter scale of magnitude for earthquakes, in the fact that it's a logarithmic scale. So a VEI 6 is going to be 10 times bigger than VEI 5 and 100 times bigger than VEI 4. So the purpose of the VEI scale is to get scientists on the same page about an eruption. So when you say VEI 5, that has some meaning about how much volume was erupted, how high an ash plume went. May 18th, 1980 eruption of Mount St. Helens, for instance, was barely a VEI 5, which is considered very large. Mount Pinatubo and Krakatoa were both VEI 6. A super eruption would be a VEI 8, or 1,000 times greater than the Mount St. Helens eruption.
While the largest eruption in the continental United States, Mount St. Helens is not the biggest in human history.
The biggest volcanic eruption in historic times is the Tambora event of 1815 in Indonesia. And that was followed by global climatic cooling and failure of the crops in North America and in Europe. There was a famine in Western Europe. 1816 has been called the year without a summer. Now, Yellowstone is hundreds of times bigger than Tambora. and the effect would be global. There would just be wet and cold weather all over the world. Well, we coined the term volcanic winter to cover what would happen after a major supervolcano like Yellowstone.
Professor Rampino has studied slices of volcanic rock to learn how previous volcanoes had changed the Earth. He paints a grim view of life after a super eruption.
Temperatures would drop on average around the world about 10 degrees Celsius. And in parts of the world, including Africa, for example, in the equatorial regions, the temperature effect would be even greater, 20 degrees Celsius. Tropical vegetation could not cope with these freezing temperatures. All above ground vegetation could be killed off. There would be a 50% die-off of temperate forests. There might be 100% die-off in tropical rainforests. This would truly be a catastrophic event on a global scale.
The lungs of the world would be in jeopardy, but not just from ash. A supervolcanic eruption in Yellowstone would release sulfur dioxide up into the stratosphere. In combination with water vapor, it would form aerosols that could block the sun from reaching Earth.
The indications are that the ash and the aerosols that are formed would stay in the upper atmosphere for 5 or 6 years. So imagine the rice production in Asia, 5 or 6 years of little or no growing season would clearly cause a worldwide famine.
And in the wake of worldwide famine would come a barren and desolate world. Yellowstone's supervolcano is home to the largest concentration of hot springs, geysers, and bubbling mud pots in the world. It doesn't have the cone shape of other volcanoes, but below the surface, there's an extinction level event waiting to happen. It's just a matter of time. A super eruption exploding from this restless caldera would devastate the immediate area. The pyroclastic flow could spread from the site in all directions, smothering people, animals, and vegetation in up to 6 feet of ash and debris. Seismic activity doesn't necessarily foreshadow a major volcanic eruption, but geologists sometimes see a link between the two.
There's no way a supervolcano, or really any volcano for that matter, can erupt without causing earthquakes. Conversely, when you have very large earthquakes, you tend to affect the plumbing systems of volcanoes that are nearby.
Martin Stryker of Berkeley, California, knows all too well the seismic dangers of Yellowstone.
One of America's worst series of earthquakes in this century fell throughout the Northwest.
In 1959, Martin was 15 years old on a family camping trip near Yellowstone. Late one evening, he was startled awake. His 2 younger brothers were reading comic books by flashlight.
And I said, what's going on? Is this a thunderstorm? And they said, yeah, we think so. And they just went back to what they were doing. But to me, it didn't feel right. So I got up and I went outside the tent and I looked right in front of me. And 10 feet away was our car. And on top of the car were 2 pine trees that had snapped off and were broken.
Martin's dad and his stepmom were sleeping in a tent nearby.
I saw that a boulder was sitting right on top of their tent, and the tent was totally covered by this boulder. I realized then that they'd been killed.
In Medicine River Canyon, 50 million tons of earth and rock, the top of an 8,000-foot mountain, thundered across a forest campground in one of the biggest landslides.
The landslide was the result of a magnitude 7.5 quake that killed 28 people.
It shows the power of the initial quake because this rock had been jarred loose on the hillside, had run down the hill, jumped over the picnic table, and landed on top of their tent in like nothing flat. My instinct was to protect my brothers. And then when I took them outside and told them that Dad and Ethel had been killed. I mean, that was a heck of a shock. The next day, a sheriff and a ranger and a farmer came by, and they got a winch and they pulled the rocks back, and that was fairly traumatic to me.
The Hebgen Lake earthquake is a deadly reminder of the geologic forces at work in Yellowstone. Deep beneath the surface, magma will try to make its way to the top. It will push and shove the rock around, producing earthquakes. It's normal for Yellowstone to have 3,000 earthquakes a year, but 2008 saw an alarming increase. In just 2 weeks, thousands of quakes and earthquake swarm rocked the area and put geophysicist Bob Smith on alert.
Front of the earthquake swarm is moving from south to north at about a kilometer a day, which is a very high rate.
The earthquakes were underneath a lake. And so that always kind of raises a red flag with the public, is because it's a little bit more mysterious when something's happening beneath a body of water. In addition, we can see that the earthquakes did migrate over time, and so that implies that maybe something's moving, maybe some fluid, maybe even some magma.
Whatever it did, it stopped. I was concerned that it was a failed earthquake sequence. We're building up this long fracture zone, get enough stress, we can have a much larger earthquake nucleating.
Then, in 2010, another alarm goes off.
Earthquakes have been rocking Yellowstone National Park all day. Researchers at the University of Utah say the park's in the middle of a swarm of quakes that started Sunday night. Since yesterday, seismologists say they recorded more than 200 quakes.
This time, the earthquake swarm lasted a month before it stopped.
You know, geologically, everyone gets excited about things that start rapidly, but we never talk about things that stop rapidly. And it's the stopping phase that we need to understand.
Recently, scientists have collected new data, giving them a better picture of Yellowstone's underground plumbing. Right beneath the caldera from the last eruption sits the magma chamber. And it's fed by a plume of magma stretching down 465 miles northwest into Montana. It's mostly solid rock, with the potential to liquefy. And scientists are closely monitoring it. Magma, or molten rock, is rising through the plume into the magma chamber at 2 inches a year.
There's no reason for it to stop, although it might come in spurts. Our images show wider parts and narrower parts, so it's like slugs of material that are flowing in a sewer line. And this restless Yellowstone caldera is truly living, breathing. Every once in a while, it bursts.
The danger is if the plume starts liquefying and moving up at a faster rate.
Natural systems can throw us a lot of curveballs. A lot of things can happen that we're not really ready for.
Scientist Jake Lowenstern is looking for a pattern connecting the supervolcano today and its 3 prior major eruptions. 2.1 million years ago, 1.3 million years ago, and 640,000 years ago.
In 2 of the really large eruptions at Yellowstone, so much material comes out, entire mountain ranges end up falling into the ground and essentially disappearing.
One 50-mile stretch of mountains simply disappeared by collapsing into the magma chamber. University of Toronto geologist John Westgate has tracked the ash from Yellowstone's prior eruptions.
It covered much of the United States. It occurs right out in the Pacific Ocean. It's even found in the Gulf of Mexico. Up in northeast Montana is a site that we're working on. The temper is over 7 meters thick. These eruptions are enormous. The amount of material erupted from them, huge.
When Mount St. Helens erupted in May 1980, it blew off one side of the mountain and triggered an avalanche of snow, mud, ash, and rock. Driven by the wind, the ash landed in 11 states and up into Canada. the amount of ash from Yellowstone's last 3 major eruptions. In magnitude and volume, each one was far greater than Mount St. Helens. Today, there's little evidence of the supervolcano's violent past. The 50 by 30 mile caldera from the last eruption was covered by lava and ash and smoothed over by glaciers. Forests now conceal the scars. But this pastoral image of Yellowstone doesn't fool geophysicist Bob Smith. He's been watching the volcano for his entire career.
This thing's been active for 17 million years. And as we see it today, it's very dynamic. When you drive to Yellowstone from anywhere, you drive uphill onto this high plateau, and the plateau is essentially the top of the hotspot. It includes the earthquakes. It includes the concept of heat flow that's driving geysers and hot springs, but it has its source deeper in the Earth's upper mantle.
It's that mysterious heat source deep in the Earth that's fueling Yellowstone. North America is a tectonic plate moving at about an inch per year in a southwesterly direction. As the plate moves, cracks and fractures allow magma to make its way to the Earth's surface and sometimes punch through as an eruption. This plate movement has left behind a trail of calderas from past volcanic eruptions called a hotspot track. From Yellowstone, it stretches nearly 500 miles to the southwest. Signs of a violent past.
All we see is what happens at the surface, but we don't know the actual players in detail of what's happening down below.
Geologist Hank Heisler, armed with an infrared camera, monitors heat levels at Yellowstone's Norris Geyser Basin, even in the dead of winter.
Right here, much of Norris is at boiling temperatures, so a lot of heat, a lot of thermal energy coming from the molten rock that's right here beneath our feet.
187 feet underground, the temperature can reach over 460 degrees Fahrenheit.
Yellowstone is still a tremendous heat source, and it's really a globally significant volcanic system. There is no place on Earth quite like Yellowstone.
And there's no place more likely to produce an earth-shattering eruption than here.